Lesson 1-4 Stem and Leaf Plots, and in this lesson, you learn to display and interpret data on a stem and leaf plot. Let's take a look at this real world application. Consumerism. Carmela Perez sells artificial joints to hospitals. She often works with the doctors who perform operations to replace joints. So Miss Perez does a lot of driving. She needs to buy a new car to replace her current car. Before deciding to buy a car, she wants to find out the miles per gallon or the MPG ratios of the cars she likes. MPG ratios for 25 cars are listed below, or the miles per gallon ratios, here they are. Now the question is, why are they called ratios if it's not a fraction? Well, remember, a ratio is a comparison of two numbers using division. This is a ratio because this is actually 31 over 1 or 31 to 1, meaning for 31, in the number 31 represents 31 miles per 1 gallon, and that's why it's called a ratio. Okay, moving on. These are your MPG ratios that she was looking at. Okay, and if you notice, it's just a bunch of numbers and they don't really mean that much when you look at them for the first time. Okay, so there's no meaning to those numbers, and it's asking us which MPG ratio occurs most frequently, which is the highest MPG ratio, which is the lowest MPG ratio. Each day when you read newspapers or magazines, watch television, or listen to the radio, you are bombarded with numerical information about food, sports, the economy, politics, and so on. Interpreting this numerical information or data is important to your understanding of the world around you. A branch of mathematics called statistics helps provide you with methods of collecting, organizing, and interpreting data. So when you talk about statistics, in this case, okay, statistics involve, okay, organizing, collecting, and interpreting data. Okay, and the stem and leaf plot is just one of those. Uh, one of those things in statistics which you can use to collect, organize, and interpret data. Okay. Graphs are most often used to display data. The misuse of graphs can lead to false assumptions. One way that graphs are often used to mislead the reader is by labeling the vertical and horizontal scales inconsistently. All of the interval marks should represent the same units. If either of the scales does not begin at 0, they should be indicated by a broken or a jagged line. For example, suppose Anna, okay, wants to convince her parents that her math grades are improving. Which graph below seems to show the greatest improvement in Anna's grades? So before we go to graph A and graph B, okay, this paragraph right here, okay, tells us when, okay, graphs are misleading. It's a review from what we did. Okay, it's a review from what we did in 6th grade and 7th grade. Okay, and these are some of the ways you can find out that graphs are misleading: by labeling the vertical and horizontal scales inconsistently. That's one. Okay. Uh, all of the interval marks should represent the same units, or else they will be misleading. And another one is if either of the scales does not begin at 0. Okay. So if it does not begin at 0, this should be indicated by a broken or a jagged line. So the green line represents graphs that are not misleading. Okay. Uh, red lines represent graphs that can be misleading. So the green lines are lines, okay, which will make you see that graphs are not misleading. Okay, so let's take a look at Anna's example and see which graph is misleading. Look at the first graph. Grades are on the vertical axis, and the grading period on the horizontal axis. Graph A, these are Anna's grades, and look at graph B. These are Anna's grades. Okay, and if you look very carefully, and if I ask you, do they show the same information? Okay, actually they do show the same data, but they are represented differently, and let's find out why. Graph A seems to show the greatest improvement. However, it is misleading. Notice the vertical axis. This distance from 0 to 60 is the same as the distance from 80 to 100. Okay, so this is what they're saying right here. The distance from 0 to 60 is the same as 60 to 80 and 80 to 100, which is not the case, because 0 to 60 is 60 units, 60 to 80 is 20 units, and this is also 20 units. Okay, this is an incorrect representation of the data and can lead to the wrong conclusions. So graph A is misleading. Okay, graph B is not. But if you want to show your mom, okay, or if Anna wants to show her mom a drastic change in her grade, okay, then she'll show graph A. But again, it is a misrepresentation of the actual data, because the graph B is the graph that should be shown, because it has all the correct information for the grades that Anna had, those 6 grading periods. Okay, going off tangent now and going back. Let's take a look at the stem and leaf plot. Another way to organize data and display it is by using the stem and leaf plot. In a stem and leaf plot, the greatest commonplace value of the data is used to form the stems. Let me highlight that. The greatest commonplace value of the data is used to form the stems. Okay, and the numbers in the next greatest place value position are then used to form the leaves. In the list on the previous page, the greatest place value is 10. Tenths, thus 31 miles per gallon, would have a stem of 3 and a leaf of. So let's take a look at the data again, and I got the data that was on the first page of our lesson, and just put it right here, so we don't have to flip pages a lot. Okay, so that's your data right there. Take that out. Okay, to make a stem and leaf plot, okay, first make a vertical list of the stems. Since the mileage data range from 12 to 50, the stems range from 1 to 5, because the tens place for 12 is 1, and the tens place for 50 is 5. So the stems range from 1 to 5. Then plot each number by placing the units digit or the leaf to the right of its correct stem. Okay? If you look at it carefully, this now becomes our stems, 1 to 5. Okay? 1, 2, 3, 4, 5. Those are our stems. Oopsie. Okay? There. Let's go back here. Let's click on that one at a time. So there you go. Those are our stems, 1 to 5. Okay? It says there, then plot each number by placing the units digit leaf to the right of its correct stem. So if you look at this, the leaves of 1, the leaves of 1 are these numbers right here, 12, 17, 18, what else? Okay, those 4. So that means my stem will have leaves of, stem 1 will have leaves of 8, 7, 2, and 3. And in order, it's 8, 3, 7, and 2, in order that I see it on that table right there. So those are my stems, 8, 8, 3, 7, 2. Oh, because I missed another 8 right there. Okay. And for the leaves of stem 2, okay, the leaves of stem 2 are as follows: 28, 26, so you have 8, 6, 6, another 6, another 3, oh, we forgot 22, and another 22 right there, and those will be my leaves, okay, right here. So 8, 6, 2, 6, 6, 3, 9, we forgot 9 right over here, okay, and then the last 2 right there, okay. And the same thing that you're going to do with the stem for 3, which are 1, 0, 1, 4, 2, 3, 1. The stems of 4, which are 47, okay, 7 zeros to 1, because there in the data there's a 47, there's a 40, there's a 42, and there's a 41. And finally, for stem number 5, it's only 0, because there's only one number beyond 49, or beyond which will have a leaf of which will have a stem of 5, which is 0, and this is that number right here. Okay, so we're not done with our stem and leaf plot. Okay, the next thing we need to do for our stem and leaf plot is that we need to arrange our leaves, okay, in numerical order from least to greatest. So again, we get our stems, okay, 1, 2, 3, 4, and 5, and then we arrange 8, 8, 3, 7, 2 in order, which becomes now 2, 3, 7, 8, 8. We arrange 8, 6, 2, 6, 6, 3, 9, 2 in order from least to greatest. Stem 3, least to greatest. Stem 4, least to greatest. And finally, stem number 5. Okay, but we're not done, because we need to create a key. So we simply here, it says that 3/1 will equal 31. Okay, you can use any of the data that you have to create your key. You can do 4/0 equals 40, 2/6 equals 26. So it doesn't really matter where you get your key from, for as long as it has a key. If it doesn't have a key, okay, it will not mean anything. Take a look at example number 1. Use the information in stem and leaf plot shown to answer each question. Which MPG ratio did Miss Paris plot most frequently? And if you look at the stem and leaf plot, okay, 26 and 31, okay, appear 3 times. So the answers are 26 and 31. What are the highest and lowest MPG ratios? So in your stem and leaf plot, it becomes very obvious that it's 50 and 12. Which line of the stem and leaf plot represents an interval of the data in which mileage interval of the data? And the second question, in which mileage interval did Miss Paris find the most cars? Let me repeat that. Each line of the stem and leaf plot represents an interval of the data. So when you talk about interval, okay, an interval is basically when you say stem 1, okay, so when you have this, and you have, let's say, stem 1 right here, stem and this is your leaf right here. Okay, and your stems are 1, 2, 3, 4, 5, and what we just talked about. Each of these stems represent an interval. What do I mean by that? Simply means that if I have stem 3, the interval for stem 3 would be 30 to 39. Okay? And the interval for stem 4 will be 40 to 49. Interval for stem 5 will be 50 to 59. Stem 2, 20 to 29. And stem 1 will be 10 to 19. It doesn't really matter if you don't have leaves in each of those intervals, but these are the intervals of those stems. Okay, going back to the question. In which mileage interval did Miss Perez find the most cars? Okay, and if you look at, let's go back here and let's recreate this right here. Let me click all over the place. Okay, in which mileage interval did Miss Perez find most cars? It's on the 20 to the 29 interval. Okay, where there are 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so there are 8 of them, and that's why that's the answer. How many cars have a ratio between 20 to 29 miles per gallon? Okay, going back to that stem and leaf plot, you will find out that there are 15 of those cars. Okay, 20 to 29 miles per gallon, that means it's going to cover, okay, 2 intervals, 20 to 29 and 30 to 39. So you're going to count the number of cars in that 22 to 29 interval and 30 to 39 interval, which will be 15 cars. Going back here again, let me refresh that again. Right here and right there, there are 15 cars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 cars, exactly what we have here. Okay, if you were Miss Perez, which cars might you investigate more closely and why? And this now becomes a subjective question. Okay, Miss Perez might want to investigate the cars represented in the last 2 lines of the stem and leaf plot, since she should get more miles per gallon with these cars than any other cars. Okay, next example. The weights in pounds of the students in a health and nutrition class are listed below. Make a stem and leaf plot of the student weights and answer the following questions. So these are the weights of students in health and nutrition class. Okay, we want to create a stem and leaf plot of these weights and answer the questions that would follow. So since the data range from 159 to 98 pounds, the stems range from 15 to 9. Okay, now we create our stem. Okay, 15. So if you notice, the stem in this example go from highest to lowest. In the previous example, it goes from lowest to highest. So it doesn't really matter which order you put them into, for as long as they are in descending or ascending order. Okay, so let's look at the stems for let's look at the leaves for stem 9. Okay, yeah, and these are the leaves for stem 9. The leaves for stem 9 I'll cross out so we don't have to worry about it. Those are numbers with 9 as their tens place value. That's 99 right there, 98, and I think that's about it. Okay, so if we look at stem 9, you have 9 and 8. Oh, the key is there, so that should be the last one that you need to do, but I accidentally clicked it, so that's our key. Stem 10, it's stem 10. Okay, 102 stem 10, 103, 108, 101, another 103. I think that's about it for stem 10, stems 10. So 8, 3, 3, 2, 1. Okay. Stem 11. Okay. Again, continue doing this until you finally cross out all the numbers. 7, 9, 6, 7, 2, 8, and that's about it. And that's for stem 11. Okay, and then continue doing that again for stem 12, stem 13, stem 14, and stem 15. And don't forget to write your key at the very bottom. Okay, now that you've created your stem and leaf plot, okay, we need to put that in order. But before that, notice that the numbers in the stem can be placed in ascending or descending order. Okay, I just talked to you about that. Okay, and well, actually it's already in order from largest to smallest, so this is already in order. Okay, the stem and the leaves are already arranged from greatest to smallest. So in letter A, what does 14A represent on the plot? It simply represents 148 pounds. Which interval has the most students in it? Again, we talked about intervals, and obviously it's going to be on the 130 to the 139 interval, which has 8 students. What is the difference between the lowest and the highest weight? You get 98 and the highest weight, which is 159. Okay, and that would be 61 pounds. Which weight occurred most frequently? Okay, it's also asking for the mode of this, and that would be 147, which appeared 3 times. Okay, and that is example number 2. And let's take a look at the last example, which will talk about back-to-back stem and leaf plot. Okay, in a back-to-back stem and leaf plot, you can also use to compare 2 related sets of data. Let's take a look at example number 3. Kyle and Mikito wanted to compare boys and girls' heights. They measure the height in inches of every student in their class. The data they collected in the stem and leaf plot they made are shown below. So boys' heights in inches are in this particular table. Girls' heights in inches are in this particular table. First things first, we need to find out the lowest value and the greatest value, okay, so that we can create our stems. Okay, in this case study of boys, the heights of boys and heights of girls, okay, are to be compared. So to compare these numbers, we create a stem and leaf plot. Okay, I don't know why these things are highlighted, or I just didn't. Nope, I just didn't do that. I just didn't hide them. Okay, so the stems would be 5, 6, and 7. Okay, because the lowest value is 57 right here, and the greatest value is 73 right there. Okay, so the stems would range from 5, 6, and 7. Okay, so put the boys on the left side, the girls on the right, or you want to do the opposite way. It doesn't really matter which. And write down the number of leaves. Okay, in this case 6. These are the leaves for 6, and these are the leaves for 5 for the boys. Okay, these for 6 for the boys, 7 the girls, and the 5 for the girls. And your key should be at the very bottom. Don't forget to arrange them from least to greatest in this case. Okay, so after you've created your stem leaf plot, you can now answer the following question. What is the height of the shortest boy and the shortest girl? The shortest boy is 58 inches tall, and the shortest girl is 57 inches tall. Okay, what is the difference in the height between the shortest boy and the tallest girl? The shortest boy is 58, the tallest girl is 71 inches. So you subtract the 2, 72 inches. So you subtract the 2, end up with 14 inches. What does 60 represent on each plot? It simply represents 63 inches. What is the greatest number of boys who are the same height? So we're basically asking for the mode, the boys, okay, and that would be 71 inches, okay, and for the girls, that would be 61 inches, okay. So there are 61 inches. Where's my girls? Okay, doesn't want to pop up. Okay, 2 boys are 71 inches and 3 girls who are 61 inches tall. What patterns do you see in the data? Okay, answers for this will vary, but the conclusion would be the boys appear to be slightly taller than girls. 7 boys are 65 inches or taller, while only 2 of the girls are that tall. So you can see, you can get a myriad of information from just one stem and leaf plot. Okay, lesson's done. On Google Forms, type a summary of what you've learned, responding to the objective, and a question you might want to ask in class. Thank you.